So if I haven't integrated yet, so we still have our integral term. We've got 4t squared over 8t squared. We're going to add on 10t over 8t second. And finally we have minus 2 over 8t second. So this is how we want to rewrite it. And if you think about it, if you're ever adding or subtracting fractions, you have to get a common denominator. You combine this denominator, and then you can just add and subtract the numerator. Kind of did the opposite thing here, so we could break it up into 7 times. All right, before we try to integrate this, we want to simplify in the way we can. So let's simplify this. So we got t squared here. We'll reduce it to t squared. So those are going to reduce. And 4 over 8 is the same thing as 1 over 4. All right, so we reduce on that one. Now we got 1t in our numerator. That will reduce with 1 power of t in our denominator. And then we're going to have 10 over 8, which is the same thing as 5 over 2. So just so we don't get mixed up, I'm going to solve this line first. 5 over 4. And we have t in our denominator with that. So we're going to do 25 liters of these cells. Let's do the last one here. So we get minus 1 over 4. T and that's with respect to all right. So let's try and integrate. And of course, if you have separate terms, you just integrate it term by term. So recall the integral is a constant. It's always whatever that constant is times the variable that's in your differential. So that's the significance of this, is it tells you what variable you're dealing with. And I'm getting a little ahead of myself. We first want to rewrite this with no variables in our denominator and no radicals. In this case, there's no radicals here, but we do have some variables in our denominator. But notice here, on our middle term, we've got t to the first in our denominator. So this is when you want to kind of recognize, and you can rewrite it as t to the negative 1 if you want, but it's better if you recognize it if it's just to the first in the denominator. So remember back here, if you have 1 over a variable to the first, it's always the natural log rule. So for me, I'm going to leave that one and not bring it up, so I recognize that's to the first. Other than that, you always just bring them up. So let's do that. All right, so integrating, we're going to leave 1/2 alone. And as I was saying, we got this 5 over 4 with t in our denominator. So 5 over 4t. And maybe this will help. What if we think about it as 5 over 4 times 1 over 2? However, it makes more sense to you. I just want to show you all we're doing is multiplying a constant times 1 over a variable to the first. So if it's ever to the first, that's our log rule. But over here, we want to bring up our t squared. So don't let this trick you. Draw a fraction line. 1 is here, 4 is here. The constants we don't care about. We're not going to move them around. We just need to get the variable out of the denominator. So we can get out of the denominator by changing nothing except for the sign of the exponent. So we're doing 25 is already up here. And that should be negative 2. One more. Negative. Let's put the negative 2. This is with respect to this one. You see that 1 over 4 to the negative 2. So I'm just going to write off to the side to show you. Another way of thinking of it is 1 over 4 times t to the negative 2. So don't let it trick you off. It's just a constant multiplied times the variable. So just get some practice and so you don't get confused on the test. So I think we're ready to integrate that. So here, we're integrating. We're actually going to use our rules, so no longer need our integrate sign. I typically use brackets. And we go to constant, which is that constant. Becomes a variable that's in a differential. All right, and then add on the next part, because we're going to just do chunk by chunk. So 5 over 4, that's a constant. Remember, constant on the one, they don't change. So we have to integrate 1 over 2. And recall that's our special case. That's the natural log, the absolute value of 2. Next term, so we have minus 1 over 4. That's our constant part. But we have to integrate the variable ahead. So what we're going to do is just like every other time, doesn't matter if it's a negative exponent, we're going to add 1 and divide by the same power. So we get t to a negative 1 over negative 1. And close my brackets to and forget it. So let's try and clean up that last term over there. We don't really want to have, a negative denominator and 2 negatives. So for this result, we get 1/2 t plus 5 over 4 ln, which you have to value t. So here, we've got negative 1/4, right? And we have negative 1/2. So 2 negatives make a positive. So really, we get plus 1/4. T to the minus 1. So if you left it at t to the minus 1 when you solve it, so you don't have to put that t in the denominator, just leave it with a negative exponent. You really only change the negative exponent if you're actually plugging in, which we'll get to.